All right, our next speaker is Ryan Blome from Dow, and he is going to be giving a talk entitled iRODS Security Challenges Within an Enterprise Environment. Take it away.
All right. Hello, everyone. My name is Ryan Blome, and I'm here to talk about some of the security challenges and development challenges my team and I have faced over the last several years of working and getting iRODS integrated into our Azure cloud environment, as well as some of the solutions we came up with to solve these challenges and some interesting ideas for iRODS. Starting with a little background about myself, I have been with Dow for around 2 years now as a senior information technology analyst. I am part of the information research team within Dow, which implements and develops new innovative software solutions for our internal customers and partners, helping to accelerate research and development innovation. My primary role through this project has been helping to shape the Lab Data Acquisition, or LDA project. Its primary functionality is the processing of data from across Dow sites throughout the globe into a searchable, centralized data storage location. A quick overview of what I will be discussing will be starting with the synchronization challenges and some high-level architecture diagrams. Then moving on to authentication and work done with that. I'll be going over the solutions we implemented for both of these challenges and some features we believe would be beneficial to all users if implemented in the future, potentially. So starting with problem one, synchronization. Currently, iRODS does not really support too much direct synchronization for third-party security solutions from services such as Azure Entra ID, AWS, or LDAP groups, requiring the need to develop custom solutions for automated security group creation and assignments. We also needed a way to assign the groups to certain collections and permission settings for our iRODS instances automatically. This increases the complexity of managing our compartmented security needs for thousands of internal users, each needing a varying degree of permissions, storage access to the data stored within iRODS. This slide represents a very high-level visual representation of our application landscape for the Lab Data Acquisition project. All of these components come together to create the LDA project. Many of our systems within Azure are used for data processing and storage, while a couple of the others are used for transporting files and viewing the data. Focusing more on the iRODS side, having a synchronization option built into iRODS would reduce the overall time required to integrate it into an existing enterprise environment, reduce internal tech debt, and remove extra maintenance we have accumulated by creating these custom sync scripts into our application ecosystem. We currently do have PAM activated as a primary login method for meta links and iRODS, which somewhat helps to simplify things. This still left us with the automated security group integration challenges. We started with the decision to utilize Azure Entra ID because Entra groups allow for organization-wide standardization of user authentication and permission management across the majority of our applications and services. This also allows business leaders to easily manage the groups they have permissions to access. We decided on a standardized naming convention for our iRODS security groups within Azure, giving us the ability to easily implement a one-to-one mapping of our Azure security groups to our iRODS security groups, which in turn allows us to manage of the user groups in both Metalinks and iRODS, all with the aim of removing the need to manually add and remove users from our iRODS instances. Our solution to the problem was to develop a bash Entra group synchronization script hosted within one of our virtual machines. Connecting to Entra ID with the Azure client and a bit of regex, we pull all of our needed groups based on our standard naming structure we set up. Combining this with iadmin commands, we then can loop through the various groups, updating the user data within both iRODS and Metalinks. We update both because we add a bit more context to Metalinks, like name and email information. So this way, we can conveniently create, update, and delete thousands of users using this process automatically. It would be quite the mess without it. The script also handles a special case for user passwords because of the C++ API basic authentication limitation. It creates a rotating randomized password stored within our key vaults for our other services to pull from, allowing our query tool to pull the correct permissions. For this diagram, I wanted to illustrate our current high-level connection flow focusing on the sync script we currently have in use. In total, there are 7 key connection points necessary to bring our synchronization functionality to life. Depicted by the blue arrows, the arrows in red depict existing iRODS connections. Several of the current connections revolve around the fact that the C++ API only allows for basic authentication, adding a good amount of the complexity of the overall logic flow, requiring a key vault and both users and passwords updated. For the short term, I'm currently working on the process of migrating our web application called SQT, which I will touch a bit more on later, over to the new HTTP API. Because the new API can support OAuth authentication, it will allow us to completely remove a key piece of the complexity from our workflow. This would reduce the number of connections down to about 5 and remove the need for the Azure Key Vaults and storing of the rotating password, as well as updating the password in iRODS there. In a scenario where iRODS would be able to communicate with Azure Client or similar systems such as LDAP, it would greatly reduce the overall complexity of getting iRODS set up into enterprise organizations similar to ours. This new logic flow would reduce the number of connections to around 3 potentially, even fewer total connections when the MetaLinks user table has been removed, allowing developers to put less focus on user security design and more on the capabilities of iRODS. Some of our known issues we currently face using our script, firstly, would be that it is a scheduled task running multiple times a day. If an issue occurs during the run, it will not run again until sometime later in the day, possibly from server or synchronization issues, requiring the run to be triggered manually by one of our developers. The script contributes to an incremental increase in our technical debt. While this might appear insignificant in isolation, such minor complexities can accumulate significantly, leading to substantial challenges over time, and of course, the need to remove the rotating password. In an ideal scenario, if possible for iRODS to be able to communicate these various security solutions, it would help with the ease of integration. Another potentially helpful option we have seen in the past is permission templates for the groups, which define various access levels to locations and editing options, potentially being supported within MetaLinks. Having iRODS taking over the permission synchronization process and updating permissions automatically at regular intervals or upon user logins would significantly streamline enterprise-level workflows. Hopefully this will give some of you some ideas for automating this process in the future. Then we move on to problem 2. Currently, MetaLinks serves as our go-to iRODS GUI management tool, offering robust features and a user-friendly interface. It is essential, however, to address some of its current limitations in permission granularity. By integrating more sophisticated permission settings, we can empower our users with better control over their data, ensuring a more secure and customized environment. The C++ API has also been a vital part of our ecosystem, but has been limited on its authentication option. As I'm sure many of you are familiar with the MetaLinks application, and it's a great tool for managing collections and querying for data with a GUI. One of its shortfalls, however, is it allows for too great of a level of elevated permissions for general users. The ability to modify, upload, and delete data and collections does not align with their internal system requirements and is allowed for general MetaLinks users. While limited to the collections of their group, however, this is still too much access. There is also not a great deal of traceability for user actions within the tool for auditing purposes. Thus, so far, this tool has been used primarily by our iRODS administrators, leading for the need for a solution that falls within our requirement specifications for our other users. These requirements led up to the development of the Scientific Data Management System, or SDMS for short, query tool, or even shorter, SQT. This application was created by me to meet the necessary requirements by only allowing users to query and download the data they individually have access to through a simple and easy to understand interface, with the option for general querying and an advanced search. In addition, this application makes it very easy to authenticate users based on their internal OAuth information and makes integrating into our other internal systems much easier by direct URL querying to the site and retrieving the results. This site is also the reason why the need for the global passwords arose. It is built upon the C++ API, which only allows for basic authentication. And since accessing the site is done through SSO, we wanted it to be as automatic as possible while maintaining the user's needed permissions. So some of the current challenges we are facing is we need to address the operation of the C++ API with a basic authentication necessitates frequent password rotations for users, complicating the login process and daily downtimes during the sync. Past instances of API crashes have raised concerns about the stability and reliability of the API. Moreover, the reliance on more internally supported software is increasing technical debt within our group and could hinder future scalability and performance. Looking ahead to this section's future, we are working towards migrating to the OAuth functionality within our HTTP API, which will remove our current issues with the C++ API, ensuring a seamless and secure user experience. Doing so should also mitigate the C++ API instability to provide the most reliable platform possible. Removing the rotating passwords is also high on the priority list, helping to make our overall process simpler. Additionally, seeing the implementation of more customizability of user permissions within both iRODS and MetaLinks would be a great thing to see going forward. Looking into the future, we're planning some cool features such as metadata drop-down searching, which will enhance the user's ability to filter and retrieve data effectively. Additionally, we foresee a new controlled file upload mechanism to ensure secure data handling and compliance to designated upload locations. Thank you, everyone, and I hope this has been giving you some new ideas and insight into some of these topics.
All right, thank you.
Anyone have any questions?
Do we have any questions for Ryan? All right, Alan has a question.
Hi, can you hear me?
Yep.
Okay, I had a clarifying question. When you say the C++ API, are you referring to the C++ REST API?
Yes.
Okay, just making sure. Thanks.
You read my mind, Alan. Any other questions from anyone? So I do have a question. You mentioned that are you testing with the HTTP API or are you actually using it in production for some use cases?
At the moment, we still have it in our development environment, and we currently are having some, not issues, more of need some clarification with the OAuth portion, getting that set up. Because right now we have the dev environment set up, connected to the HTTP API.
Okay. So no major issues regarding usage so far, just questions around OAuth.
Yeah, so far it has been working pretty well and been much more stable in our dev environment. But yeah, but now it's still using the basic authentication, just like the REST API, but it's going to need some work with the OAuth.
Okay. Excellent. All right. If there's no more questions, then I guess, Ryan, we'll let you go. Thank you.